Hey guys, welcome to question MM308 of the Maths Methods Fortify study guide. So in this question we've got the graph of f of x equals x squared, as shown here. We've got this value of k. And our first part A, says find the area of the shaded region in terms of k. Awesome. So there's multiple ways to do this. I'm just going to do the one way, or the method that I would probably do it in an exam. If you want to check out the other method, it's in the work solutions. So check out that work solutions document. So to find the area of this shaded region, what we're going to need to do in the method that I'm going to do is get the total area of this rectangle here and then minus whatever's under this graph. And that's going to leave this shaded area here. So our area is equal to our rectangle minus the area under graph, right? So the area under f of x. Awesome. So what's our rectangle? Well, the area of a rectangle is length times width. So length times width. What's our length though? So we know that our function is x squared, which means our x value is k, which means our y value here is going to be k squared, right? So our rectangle is going to be k, or our length, which is k squared, times our width, which is k. Right? So k squared times k minus the area under this graph from 0 to k. Okay, so from 0 to k, the area under x squared dx. This is our first mark out of the 2 marks here. So from here, we get our k squared times k is k cubed. And then we can say minus x squared, the integral of that is x cubed over 3 from 0 to k. K squared then minus, we sub our value in, so k cubed over 3 minus 0 cubed over 3, which is obviously just 0. So we then get k cubed, take k cubed over 3. Just doing all the steps here, we get 3k cubed over 3 minus k cubed over 3. So I've just made the denominators the same, which means I can then say that the area is equal to 2k cubed over 3. It's our second mark and final answer for that, guys. So our area is equal to 2k cubed over 3. That's it for part A. Let's move on to part B. Now part B is a 2-mark question again. And it asks us to, well, firstly it says the shaded area above is equal to the area bound by the graph of g of x, which is equal to f of x on 2 plus 1, the x-axis, and the lines x equals 0 and x equals 2. Find the exact value of k. Awesome. So we know that the area here, which is equal to 2k cubed over 3, that is equal to the area under f of x on 2 plus 1. So f of x on 2 plus 1, we simply sub in x on 2 for our x values here. So we get x on 2 squared, and then we add 1. So plus 1, which means x squared over 4 plus 1. So that's our g of x, right? So the area under this graph from 0 to 2, as per the question, is equal to this, okay? So area, actually let's say, area is equal to, from 0 to 2, of x squared on 4 plus 1 dx, right? Which is equal to 2k cubed over 3. Sweet. So what we're going to do here is actually just evaluate this as normal. So we're going to go through our integration process, which means x squared on 4, we're going to add 1 to the power, so x cubed, and then divide by the new power. So we get 4 times 3, which is 12, plus x from 0 to 2. Awesome. And then from here, we're just going to sub in our values as normal. So we sub in our 2, so we get 2 cubed over 12 plus 2. And then subbing in our 0, we get minus 0. Right, because this is just going to all be 0. From here, we can say that 2k cubed over 3 is equal to 8 on 12 plus 2. So 8 on 12 is the same as 2 on 3. So 2 on 3 plus 2, which is equal to 8 on 3. Awesome. So we can see that 2k cubed over 3 is equal to 8 on 3. This is our first mark. Okay, so we do have to do a fair bit of working to get to our first mark, but this is important. So I'm going to multiply both sides by 3 now, because our goal here is to find k, right? That's what we're looking for. So I'm going to multiply both sides by 3, which means I get 2k cubed equals 8, k cubed equals 8 divided by 2, which is 4. So therefore k is equal to the cubed root of 4. That's it. So that's our second mark, guys, and our final answer for part B. If you have any questions, as always, hit me up in the comments below, but let's move on to part C. So part C is a 2-mark question, taking a bit of a different route, I guess, or a different kind of question. So 2 marks. And it says, find the coordinates of the points of intersection between the graphs of y equals f of x and y equals g of x. Awesome. So as soon as we see find the coordinates of points of intersection, we need to make the graphs equal each other, right? So we're going to say that f of x is equal to g of x. We know f of x is just x squared. And we know from the previous question that g of x is equal to x squared on 4 plus 1, right? So to find the points of intersection, we're going to need to solve for x first, okay? So we're going to minus x squared on 4 from both sides. So we're going to get 3x squared on 4 equals 1. Multiply both sides by 4, we get 3x squared equals 4, x squared equals 4 over 3. And then the square root of both sides, we get plus minus square root of 4 on 3. So plus minus 2 over root 3. Awesome. What we want to do actually is rationalize this denominator. We don't like square roots on the bottom, which means we're actually going to get x equals plus minus 2 root 3 over 3. Okay, so I've just multiplied this by root 3 on 3, which rationalizes that. So this is our first mark. Okay, we found our x values of the points of intersection, and now we need to find our y values. So the easiest way to do this would be to sub back into f of x, because it's just x squared. We can kind of easily do that. So from here, we get f of 2 root 3 over 3 is equal to 2 root 3 over 3 squared, which is equal to 4 on 3. Right, because it makes sense, because this is root 4 on 3, so that squared is just going to be 4 on 3. F of negative 2 root 3 on 3 is going to be negative 2 root 3 on 3 squared. And because negative times a negative is just a positive, that's also going to equal 4 on 3. So therefore, our points of intersection are going to be 2 root 3 on 3 and 4 on 3, and then negative 2 root 3 on 3, 4 on 3. That's our second and final mark. So guys, that's our final answer for this part C. If you have any questions, as always, let me know, but let's move on to part D. Guys, part D is simply a 1-mark question. So we can use our CAS for this. We do have our CAS available in this question, remember? So D is 1 mark. And it says, hence find the exact area bound by the graphs of y equals f of x and g of x, okay? So g of x, as always, is x squared on 4 plus 1. So we know that our g of x is above f of x, right? Because we've actually moved g of x up a bit, so it kind of looks like that a little bit. Awesome. So that means that our area is going to be from our points of intersection, or between our points of intersection, of g of x minus f of x, right? Because that's our formula for working out the area between two graphs. Our points of intersection, our first one was negative 2 root 3 over 3, and our second one was 2 root 3 over 3. G of x is x squared on 4 plus 1, and then minus f of x, which is x squared. So minus x squared dx. Now, because this is a 1-mark question, guys, I would actually just chuck this straight into my calculator and write down the answer. So if we put it in our CAS, what we get is 8 root 3 over 9 units squared. And that's our first mark, and our only mark for this question. It's just a 1 mark. So 8 root 3 on 9 units squared. Don't forget your units squared. Whenever we deal with area, we need to make sure we have units. But that's it for this question, guys. Please hit me up if you have any questions in the comments below. But otherwise, thanks for watching, and I'll see you in the next video.